Hi there, Science 10. So this is the video for Lesson 8, which is human effects, human impacts on the climate. So as I've said to you before, the human impacts on the climate that are happening just now are mostly due to the release of these greenhouse gases. So in Lesson 7, I told you about greenhouse gases, how when infrared radiation strikes the molecules of greenhouse gases, they become more excited, their bonds become more excited, they are kicked into motion, and they kick into motion other molecules in the atmosphere like nitrogen and oxygen and increase the overall temperature. It's that absorption of infrared radiation and excitement of the molecules which causes that temperature increase. If we didn't have these greenhouse gases in our atmosphere, including water vapor, methane, carbon dioxide, the Earth's atmosphere would be some 30 degrees colder than it is. Commonly given examples for the greenhouse effect would be, Mars. It has a very thin atmosphere and virtually no greenhouse effect. It's much colder. It's partly colder because it's much further from the sun, but Venus is given as an example of an enhanced greenhouse effect. It has very thick greenhouse gases, and they reabsorb virtually all of the infrared radiation that's radiated back from Venus. So it's a hot house. You don't want to have too much of a greenhouse effect. You don't want to have too little. So I want to look a little bit about what's been happening with greenhouse gas concentrations. This is just for carbon dioxide, although other greenhouse gases have behaved in a really similar way. So a guy named Charles Keeling, about 50 years ago, actually, well, more than that now, more like 60, started to record carbon dioxide concentrations in the air on the summit in Hawaii. He did this because that's a location on the Earth. He reasoned that the carbon dioxide will have become very, mixed up by the time it got there. The temperature, the carbon dioxide concentrations would not be influenced too much by, say, nearby industry or other things, because these peaks in Hawaii are so remote from any major projects or activity. And what he found surprised him, which was that the temperature, the carbon dioxide concentrations in the atmosphere, which were around 300 and something when he started to record them, he found that they were going up. He was only recording, I think, by the time he was making this finding, this was in the 1970s, so he was recording that information back then. What's happened since then is the concentrations of greenhouse gases have steadily increased. It's almost like an exponential, like an upward curve right here. It doesn't just appear to be ticking along like as if it were a line. It's kind of scooping up a little bit. There are many lines of evidence that show that the greenhouse gases, the carbon dioxide that's being released, it's being released when we're burning fossil fuels. Isotope ratios are used to show that that the fossil fuels are the source of the carbon dioxide, which is hardly surprising. Like, what else is changing so radically on Earth? It's the fact that we're burning so much coal and petroleum. In fact, if you look from 1850, before we started using so much fossil fuel at all, the concentrations were something like 280. So even by the time you're at 1960, those concentrations were already some 30 parts per million higher. I said in my last video how I found a resource that said, oh, well, we're nearly at 400 parts per million of carbon dioxide, and that was considered extreme when this one web page was published. And then, of course, I showed you in the video that the concentrations are now there's nowhere on Earth where the concentrations are as low as 400 anymore. If you look at carbon dioxide concentrations on the Earth's surface, you see we can click on this map right here. Right now in northern Canada, we're sitting at 430. In the Amazon basin, where there's lots of photosynthesis, we're sitting around just a little over 400. This marks the fact that not only have carbon dioxide concentrations been going up, but they're still going up. They continue to increase as we burn more and more fossil fuels. This has to do with our increased population. It also has to do with the increased industrialization of human beings. It has to do with burning forests. There's a lot of factors that are affecting it. You might ask why the zigzag pattern. That is to do with photosynthesis. So it goes down. There's more land on Earth in the northern hemisphere. So when we go through summer into fall, there's lots of late spring, summer into fall, there's lots of photosynthesis that starts to happen. That brings the concentrations down, but they bounce back up when those same products of photosynthesis decay and release the carbon back into the atmosphere. The overall trend, though, is of an increase. So it's increasing because of fossil fuels, and it zigzags because of photosynthesis. So that's the Keeling curve, and there's other curves or steady increases in greenhouse gases that behave the same way. We've got carbon dioxide, methane, CFCs are also increasing in a steady way. Another major greenhouse gas is water vapor, but of course, it shouldn't be surprising that water vapor as well is going to respond to increases in temperature from other greenhouse gases. As there is a greater heat in the atmosphere, more water can evaporate and become water vapor, which can also absorb more heat. Climate is a complicated thing, of course, because when water vapor rises high enough, it makes clouds, and clouds reflect the sun's light. So water vapor can kind of reduce the overall impact of climate change, and positive and negative, what are called feedbacks like that, make it difficult to predict the exact extent of the impact of climate change. There's uncertainty, but is CO2 going up? Yes. Is the temperature increasing? The answer to that question is also yes, based on a lot of lines of evidence, including direct temperature measurements over the last 100 years. We see here, the yellow line here is just sun's activity, showing that even though the sun's activity, the amount of sunlight, energy from sunlight has been going down since 1950, the temperature's gone up. Some people have said, oh yeah, it's all about the sun's activity increasing. Well, the sun's activity has decreased and temperatures have continued to increase. The evidence is that this comes down to an increase in the concentration of these greenhouse gases that I talked about, and of course I showed you that diagram or those applets in the last video that showed how it is that these different greenhouse gases absorb infrared radiation and transmit it to other gases in the atmosphere, increasing temperature. So there's lots of effects of greenhouse, of an increase in temperature, right? We see that increase in temperature here. That has many effects that are knock-on effects to the environment. I should mention that a lot of the effects I'm going to show you also are influenced by human activity. It's not just climate change that's causing these problems, but these problems can be made worse by climate change. One is desertification, and that's exactly what it sounds like. That's when the deserts of the world are expanding. So that's happening wherever there are deserts and there's an increase in temperature. If less water is available for photosynthesis and the temperatures are going up, vegetation can die and deserts can expand. This picture here is taken one of the poorest countries of the world in Chad, where a lake in southern Chad called Lake Chad has been steadily decreasing in area. So if you look at the lake in 1973, it covered these two big blobs of space right here. And if you look at it in 2001, this is now just a green space here and here, and all that's left is this shallow patch of water. The Great Lakes of the interiors of continents in the world have been decreasing in area and in depth. And if you're really far from the ocean, it's really important to have other sources of water than the ocean, both for precipitation and for just directly for agriculture. When these lakes in the interiors of continents decrease, you've got big problems when it comes to having agriculture happen in those areas. So the desertification has really large health and security implications. The one that does come up a lot, of course, is sea level rise. Sea level rise has to do with the impacts on the ice caps. In fact, I'm going to go over here and show you this first. This is Greenland. And by the way, down here, this is Antarctica. Greenland and Antarctica share something in common, which is that they're covered by a cap of ice, a cap of glacial ice. So I'm not talking about sea ice right here. I'm specifically talking about glaciers or glacial ice. When this stuff melts, it can increase it, and it melts and it goes into the ocean. That can increase the level of the ocean. In other words, it can cause the sea level to rise. When the oceans are getting warmer in general, the oceans will expand and the sea levels will rise even more. Here's a great video for you. They watched a glacier that was melting, calving into the ocean. So here we go. So we see what they went there. So it was probably in the late summer of whatever year that was, and they found that this glacier was slowly calving, breaking off, and collapsing into the ocean and melting. And of course, when this is happening, once this ice from the land that covers the land has melted into the ocean, that can raise the level of the ocean. If all the ice cap of Greenland melts, that will have a huge impact on sea level rise and affect many other countries, especially countries with low average altitude. So I want to get into that in a moment. So Greenland, let's get to Bangladesh. So Bangladesh is a country that's it's got the Ganges River flowing through it. It's basically a massive river delta just south of the Himalayan mountains. Bangladesh has a very high population density. There's something like, I believe, 4 times the number of people in Bangladesh as there is in all of Canada. And for some perspective, Bangladesh is a fraction of the size of BC. Maybe, I don't know, I'm guessing a third or a quarter the size of BC with 4 times the population of people. So it's got a very high population density living in a very low altitude country. The concern is that as seas expand and as they rise because of ice melting into them, that there will be sea level rise. There have been a lot of projections about this topic that have been that have been created. So basically, here we are in Bangladesh. The dark green is heavily populated areas. As the sea levels rise from here, you add 1 meter and you are flooding the outer delta of the Ganges. And so 15 million people live in that area, and hey, they've got to move. They need to go somewhere. That's going to cause knock-on effects. Where are they going to go? They're going to have to go elsewhere in Bangladesh or maybe elsewhere within India. That kind of mass movement of 15 million people, it's going to have large political effects, and a lot of people are going to lose their homes. And of course, this land that you see right here is excellent farmland. We're losing land here that would be used for agriculture, and so mass starvation is also a concern. If it rises 1.5 meters now, 18 million people are affected, and so on. Bangladesh is not alone in this. There are low-lying island countries all over the world that could be affected by this kind of sea level rise. Bangladesh is just an extreme example because it has such a high population density. But if you're in, say, the Maldives with an average elevation in the Maldives of something like 6 feet, there's a concern that a country like the Maldives could entirely disappear. So the entire population of many of these island countries in the Pacific and other oceans could literally have to leave the country because the country disappears and go elsewhere. So this kind of mass movement that might be necessary could have very large political changes and other negative effects on the environment, like on food production. So sea level rise is a big concern when it comes to climate change effects. Something that is also related to climate change, could be caused by it, but can also affect it, is loss of forest cover. So what you see right here is a map of Borneo, and it shows the forest cover in green in Borneo in 1973 and in 2010, and of course that's 10 years ago. And a lot of what you see as green here is now red. In other words, the forest has been lost. It's been used for making palm oil plantations and burned for other agricultural purposes. This is tragic because of all the animal habitat that's being lost. It's truly awful, but why should you care otherwise? Well, one other reason to care otherwise is the fact that this forest here is a sink for carbon. A lot of carbon is stored in wood. We know that's when we burn wood, we're releasing carbon dioxide. That loss of that carbon could lead to a further increase in the carbon dioxide concentrations in the atmosphere. So higher temperatures, more forest fires, more carbon dioxide released, well, more forest fires. So Borneo is an extreme example of forest loss, but if you look at, say, where are the great forests of the world? They're in Canada. The greatest forest in all the world is in Siberia. If we look here, all this land stretched across here, like here, for example, and here in northern Siberia, that's currently forested with an increased risk of forest fires. That area of forest is in danger, and the carbon dioxide stored in that area of forest is also in danger of being released into the atmosphere. So we've got something that could be affected, and then itself could be a cause as well. Extreme weather events are a big concern when it comes to climate change. Hurricanes are a result of, well, of course, you have the Coriolis effect that is happening, and I've talked to you about the Coriolis effect. Hurricanes, that spiral pattern of the hurricane results from the Coriolis effect, but the spiral pattern will be more powerful when there is higher sea level temperatures or higher temperatures. Well, particularly for hurricanes, higher sea level temperatures. Hurricanes respond to temperatures in the ocean, I should say, temperatures of the ocean surface. With higher ocean surface temperatures, hurricanes can be more powerful. They make the news a lot more than a lot of other extreme weather events because of what they do and where they do it. They cause really nasty flooding, and of course they do it to the United States. And the United States, we hear a lot from them because of their media being right next to us and them being such a developed country. So these hurricanes are able to, powered by warm sea level surface temperatures, they can destroy huge areas of forest, but also of habitat, but also of buildings in the southern and southeastern United States. Hurricane Katrina was an extreme event, not only because it was a record-sized hurricane, but because of where it hit. It hit New Orleans, the city of New Orleans in Louisiana. And because New Orleans, a lot of it is circled by dikes. It's at a very low altitude. The levees north of New Orleans broke due to flooding, and New Orleans itself was flooded. Some 2,000 people died because of that hurricane. Can people say that one hurricane was for sure caused by climate change? No. What can be said is that hurricanes like that, events like that, are made more likely by climate change. It's not about certainty, but it's about increased likelihood, increased probability of something bad happening. Extreme weather events like hurricanes, but also extreme high temperatures, are expected to be caused by an increase in the average temperatures. The last one I guess I wanted to deal with, oh no, there's two more I wanted to deal with. One is flooding. This is one you hear less about, but arguably affects more people. So flooding has its strongest effects in Southeast Asia, like in the Philippines and Indochina, but also in coastal China. Wherever you can get very high levels of rainfall, like in the monsoon, if very high levels of rainfall become extreme levels of rainfall, well, look what you can get. You can get the streets are flooding in this town in the Philippines with a very high population density. Lots of people can lose their homes, die. You can lose agricultural land because the soil is ruined. There's lots of really negative impacts that you can get from flooding. This is a result of high levels of precipitation, like from the monsoon, but it's also related to land use. As forests are cleared in the hilly areas around these cities, they lose their ability to store water and to release water from rain more slowly. It basically all falls off the hill at once, and the levels of water increase. So flooding is a complicated thing, and it's not just climate change. We have to be careful with climate change. We can't blame everything on it, but flooding events are made more likely by climate change that is happening now on this, that has been happening for some time and is happening more in the present day. The last thing I want to talk about just briefly is not actually related to climate change. It's related to the carbon dioxide itself. If you've ever drunk any of that, like soda water, just like carbonated water, you notice it got a kind of a sharpness to its flavor. That's because soda water, carbonated water, is slightly acidic, so it naturally tastes kind of sour. And that is because of the carbon dioxide that has been pumped into that water. Because what happens when you add carbon dioxide to water? Some of it's freely dissolved as carbon dioxide in the water, but what happens with it also is it reacts with the water molecules. You make this stuff called carbonic acid. The carbonic acid can then release what are called free hydrogen ions. These free hydrogen ions are acidic. Carbonate ions, they can then join on to carbonate ions, and those carbonate ions can become bicarbonate, like in baking soda, but they are now not available to shell-forming animals, like coral, like mollusks, and so forth. So what can happen then with fewer free carbonate ions in the water is the animals with shells, like coral and snails and so forth, that live in the ocean, they can't form shells as effectively, and so they end up being smaller. So as carbon dioxide concentrations increase, most of the carbon dioxide is absorbed by the oceans. Most of it doesn't actually stay in the atmosphere. It's mostly absorbed by the oceans. Being absorbed by the oceans, pH goes down because it gets more acidic, and less carbonate is available to shell-forming animals. So this isn't a climate change problem. This is a carbon dioxide problem, but it is also a very real problem that is having an impact as a result of our fossil fuel consumption. So that's everything I wanted to say about human impacts of climate change, and I hope you find this useful. Hey there, Science 10. So just continuing lesson 10, or lesson 8, I should say, human activity and climate change. So part of the notes for this is looking at where climate change is going to happen, or what the effects are expected to be of climate change in different parts of the world, and provide for you a map to put these out, write these on too. So this really relates directly to your climate change project. I've written up notes up on the board that kind of show the locations of some of these problems that I'm also going to be outlining in your screen-based lesson. So here's where they fall out for different parts of the world. So looking at my coding here, So S just means it's a greenhouse source. That's part of the world where they're mostly coming from. X is your extreme heat effects. D is desertification. F is forest or forest fires, which can be a source for greenhouse gases. R means sea level rise. I means melting ice cap. A is ocean acidification. W is flooding, and H is hurricanes or extreme weather. A punchline I want you to take from this is that the effects of climate change are expected to be global. Very few parts of the world, with the possible exception of New Zealand, are expected to be unaffected. So, from my knowledge, here's where I see these impacts happening. So, if we look at North America, first of all, major source of greenhouse gas, forest fires, desertification, sea level rise, like in Florida, could be issues. Here's South America, ongoing forest loss, as well as desertification, can be an issue there. Africa, not causing the problem, but desertification and extreme heat events, as well as forest loss and fire as a source of greenhouse gases, a problem there. Here's Europe. Europe, of course, is also a source of greenhouse gases as an economically developed region, but it's got a lot of low-lying altitude places which are subject to sea level rise as well, and I could have put an X there for extreme heat events. Well, that's all relative. The Middle East, Saudi Arabia right here, I guess we could almost put down S for that because so much oil and gas comes from there, but desertification and extreme weather can affect this region as well. India, massive population, per capita basis, not a huge greenhouse gas impact. If you're living in India, you don't have the same prosperity and they don't have the same impact on the climate as we do here in Canada on a per person basis. Here's Southeast Asia, so forest loss in Indonesia, Australia, desertification, extreme weather. Here's China, huge source of greenhouse gases, China, but of course, how would it not be? It's a manufacturing hub globally. And we see here for Siberia, forest fires and also fires in the permafrost could release more greenhouse gases. So, a couple other things. The low-lying Pacific Islands, there's lots of little tiny island nations or micro-states scattered across the Pacific Ocean. Many of those have an altitude no higher than even like 6 feet. With sea level rise, they may well become flooded and the countries could actually just go entirely out of existence. And then ocean acidification. I put the A right there because that's where the Great Barrier Reef is. Some of the great coral reefs of the world are located in this part of the world. And lastly, I didn't want to stretch out Antarctica, so I didn't scale it the same way. This is kind of a map of Antarctica, an I for ice cap melts. So that, from my knowledge, is how these different problems related to climate change all map out.